So here's a numerical example of the multivariable chain rule. And I would suggest as we start to read through this problem that we start to draw a diagram, because we know from our previous examples that diagram is really helpful in setting up these chain rule calculations. So initially we're told that z is a function of u and v. Okay, so that means z depends on u and v. And then in our next line, we've got formulas for u and v. And we can see that u and v somehow depend on the variables x and y. So we're going to draw x and y there. And that at least captures the relationships that we're seeing in those first two lines. Okay, then we're given a little bit more numerical information. We're told the partial derivatives of z with respect to u and v at a certain point. And what we ultimately want to find is the partial derivative of z with respect to y at a certain point. Okay, so since we're trying to find the partial derivative of z with respect to y, let's start by using our diagram to calculate that. So this time we're using the subscript notation for partial derivatives, whereas we were using the delta notation in the previous video. So it's probably good to be comfortable with both notations. We need to look at all the paths from z to y. So there are going to be two of them. That means there are going to be two terms when we calculate partial derivative of z with respect to y. Okay, all the derivatives that we're going to write down are going to be partial derivatives, because in this level we're seeing multiple variables, and in this level we're seeing multiple variables as well. So that means every variable that we see in this diagram depends on multiple other variables. Okay, so according to our diagram then, we're going to have z sub u times u sub y for our first path, plus z sub v times v sub y. Great, now we actually have formulas for u and v in terms of x and y. So that means we're going to be able to calculate u sub y and v sub y. So let's go ahead and calculate that. This is still giving us z sub y here. So we've got this z sub u times partial of u with respect to y is going to be 3y squared. Plus we've got z sub v times v sub y is going to be x minus 6y. Okay, so now comes the point where we're going to try to sub in. What we're trying to find is z sub y at the point where xy equal 1, 2. So let's see what happens as we sub in xy equal 1, 2. Well, notice that we've still got this z sub u and z sub v in this formula. So let's look back at our given information. And sure enough, we're given some values for z sub u and z sub v. We've got them at the top of the screen. But those values apply for a certain combination of u and v values. So what we should do, just to make sure that the information in the problem is really pertaining to the correct point, we should move from x and y values to u and v values. We know how to do that because we have formulas for u and v. So let's just confirm that at the point xy equal 1, 2, let's calculate what u is equal to and what v is equal to be sure that that information in the question is speaking to the correct point. So remember, we were told u is equal to 3x plus y cubed. So if we sub in our x and y values, yep, we get 11. And v was equal to xy minus 3y squared. So subbing in our x and y values, that looks like 2 minus 12, so that's negative 10. Okay, so all of this is just to say that the point xy equal 1, 2 corresponds to the point uv equal 11, negative 10. See, the information about z sub u and z sub v that we've got correspond to the uv value of 11, negative 10. So I could see that some people might be tempted to just sort of gloss over this and say, yeah, I'm just going to trust that the problem is telling me the correct point. But if you really wanted to convince yourself that you've got the correct information, I think it's worthwhile just to go through that quick calculation. Okay, so that's telling us that the z sub u and z sub v values in the problem are associated with the point xy equal 1, 2. So we're free to just use z sub u equals -3 and z sub v equals 4 to do our calculation. Okay, so I'm going to put all this stuff in a box. Anything that appears in this box can now be substituted into our expression to get our answer. So finishing off our calculation then, z sub y is going to be z sub u. Well, at the point that we're talking about, z sub u is equal to -3. That gets multiplied by 3y squared. Okay, y is 2, so 3y squared is 12. And then we're going to go plus z sub v. Well, at the point that we're interested in, z sub v is equal to 4. And then we are, looking back at this step here, then we are subbing into the x minus 6y. So if x is 1, y is 2, then x minus 6y gives us -11. Okay, so here's our answer coming up. We got -3 times 12 plus 4 times -11. That gives us -80. And that gives us our numerical value for z sub y. So that gives us a little bit more practice with setting up a diagram, using the diagram to calculate the partial derivatives. And we also had a little bit more discussion about how we actually sub into these expressions. Always best to take your point xy, turn it into u and v coordinates so you can be sure that you're plugging in the correct information. Thanks for watching.